So now we're being asked about concavity. So we're just continuing on. We're using both first and second derivative all on the same question. So here was our worked out problem. Remember, it started with x minus 5 and then x squared minus 10x minus 50. That's where we started. And then I distributed this through and got this function. Then I found the first derivative. And now it's asking about concavity, so I'm going to find the second derivative. So power rule, drop the 2 to the front and multiply, subtract 1, drop the 1 to the front and multiply, subtracting 1, the x goes away. Here's my second derivative. So now I set my second derivative to 0, factoring out a 6. My values, so there's no x with my 6. So the 6 is kind of a mute point. It just expands it. So there's no value to solve for. The only thing I have to solve for is where my x is. So I have x minus 5 equals 0. I'm going to add 5 to both sides, so I get x equals 5. So with second derivative, when you set your value to 0, what that is your possible point of inflection. Possible, all right? So just like with the critical points, you come over here, you identify your function. This is my second derivative, so it tells me what function to use. I now have broken it up into 2 intervals, so I'm going to test. So at the second derivative, I want all values less than 5, so I can pick 0. Come over here, 6 is a positive. 0 minus 5 gives me a negative. So this interval is negative, which means it concaves down. Make sure you use the concavity symbol because it identifies, again, another way to identify whether you're doing first derivative or second derivative. First derivative, we use arrows. Second derivative, we use the concavity. All right, now I'm going to test for all numbers greater than 5. So I'm just using 10. Again, my 6 is positive. 10 minus 5 is positive. So I have a positive concavity here. So because it went down and then up, this number 5 is my point of inflection. That's exactly where my graph is going to change concavity. Okay? So the question is, the function f is concave up on the subinterval. So this is concave up on the subinterval 5 to infinity. This is my concave up. I'll write it up. And then the function f is concave down on the subinterval. So here's where it's concave down. So it's concave down from negative infinity to 5. Okay. And then the function has an inflection point at x equals. So again, we don't have to find out what the y is on the MyMathLab. So at x equals, this is my point of inflection. So at x equals 5, that's my inflection point. And then the last thing is choosing a graph. So I'm going to go back and rewrite my first derivative test chart. So let me go back and redraw that. So it was critical points at 0 and 10. We went up, down, up. Okay, so now you're with the graph, you're just choosing a graph. So you're looking at the graphs and you're going, okay, which one fits the criteria? So if I were to graph this, and again, I don't know what the y value is, but I do know what the x values are. So I know at 0 something, I have a maximum value. Well, this would be easy. If I plug 0 in here, I get negative 5 times negative 50. So my max is at 0, 250. Sorry, I said negative 50. So 0, 250. My minimum is 10. So I know my minimum is going to be 10 something. So if I plug 10 in here, I get 10 minus 5 is 5. 10 squared is 100. Minus 100. So the hundreds go away. So 5 minus negative 50 gives me a negative 250. Okay, so my graph is going to be where my maximum is at 0 to 50. So again, I'm just making it fit my graph. My minimum is at 10, negative 250. So it's somewhere here. So that's my minimum. And my point of inflection is at 5. 4, 5. So 5 something. Well, if I plug 5 into here, 5 minus 5 is 0. 5 squared is 25. Minus 50 is a negative 25. Minus 50 is a negative 75. Well, the minute I have a 0, this whole thing goes to 0. So my point of inflection is at 5, 0. So it's right there. That's my point of inflection. So my graph, I have everything I need. In this interval, it's going up. It hits my max, and then it goes down. So it's going up, hits my max, and starts heading down. It has to cut through my point of inflection, because that's where it changes concavity. It hits my minimum, and then starts going back up again. Okay? So that gives you an idea of what the graph looks like. And now you can go through, well, on this particular one, I can eliminate B and D, because B and D, it's flipped. So look at what your graph is doing, eliminate, and then you can just concentrate on A and C. And in this case, the graph is A. So what you want to do is, you know where it is your y-intercept. We found that. The y-intercept was at 250, right there. You know your x-intercepts. So you can look for, okay, where does it cross at 5, and then those other two values, 5 plus or minus 5 square root of 3. So you can punch that into your calculator and find an exact value if you want. But it's the max and the min that's really going to help. And it's also your point of inflection. Okay? So there you go. We've put everything together. And now you should be good to go.